How that will get heated up? Okay, let's not bother. So what is the power of that heater coil? 20 watt. It will supply a constant power, the heater, and it will supply power to the ball. In a room. So what is a room? There's a room. In a room at 20 degrees Celsius. So what is the temperature of the room? Room is 20 degrees Celsius. At T equals 0, there's a situation is what I'm showing. So what is the temperature of ball? Should be 20 degrees Celsius. No doubt. Okay, I'll switch on the heater. Is heated by means of 20 watt heater. Mass of ball is 1 kg. The temperature of ball becomes steady at 50 degrees Celsius. Temperature of room will be fixed. Temperature of room will be fixed. I have to write it inside. There's a room, no? It's inside that one. So the same heater coil. This is imagination. If you are able to do well, nice. It's good. Actually, if you can imagine like this, no? It'll be very easy for you to write expressions. That's why I just took help of the diagram. What is the temperature of room? Room temperature will be same as it is. The heater will supply heat to the ball, no? So then what is telling? It will attain temperature of how much? 50 degrees Celsius. This is a room. At some time, we are not bothered at some time. Now, what actually happens here? It's telling the temperature of ball becomes steady at 50 degrees Celsius. Okay, till now, let it be that one. So now steady. Steady means here what happen? It will be emitting. And also will be absorbing. No? I think this is one basic property of any body. No? Okay, agree this. The arrows, look at that arrows, emission as well as absorption. Okay, let's go for Newton's laws of 20. So what all heat supplied by the heater coil? With that heat, what happened? The temperature of the ball will attain 50 degrees. Now it's a steady state, means temperature of that will be 50. What it does, what all heat supplied by the heater coil, or what all the power supplied by the heater coil, that it will give out. So how it will give out? It will it will be emitting and also be absorbing. But the resultant radiation, how much it should be, the resultant power radiated should be how much? 20 watt only. I mean, then only temperature can be constant. Able to get this particular point, the ball, what will happen? Will be emission, will be emitting and also absorbing. Will be giving out energy and also absorbing. But the resultant should be equal to how much? 20 joules per second. So that's what happens here. So now, so what we can write here? What all heat supplied by the heater to the ball? What it will do? A part of energy it will emit. It will emit and also it will absorption. So shall we go for Newton's laws of heating? Power supplied by the heater should be equal to net power radiated by the ball. What do you mean by net power radiated? How you write? We don't know that K, no? What is that K? Mass, specific heat, emissivity, all things will come into picture. We don't know that. That should be equal to temperature difference. Temperature of the ball is how much? 50 minus 20. That of surroundings. This room will become surrounding. So with this, I'll get the value of K. So K will be definitely 2 by 3. Keep it. This is going to help us a lot. Later on, okay, later on, let me color it. Then I'll post it. Okay, okay, what is the value of K? This one. Sir, it is cooling. No, it is getting heated up. No. So Newton's laws of heating is what I applied it. Okay, let's get into the discussion of find the rate of loss of heat to the surrounding when the ball is at 50 degrees Celsius. Tell me what you should do. what it does, rate of loss of heat. What all the heat supplied by the heater coil is what that will be given by the ball to the surroundings, no? The resultant. Okay, the net heat radiated by the ball is nothing but equal to the net heat received by the heater coil. So therefore, now shall we put for what is the first one? So this is what our discussion. Now we are entering into the problem. This is the initial heater is switched off. Heater is switched on. Okay, now we'll get into the numerical part. Okay, now what shall I write here now? 20 watt only. What should be the answer for the first part? Find the rate of loss of heat to the surroundings. What all the power? The power supplied by the heater is what? The power lost by the ball to the surrounding. But sir, it should have been more. No, the net power. Power loss means it will emit and it will absorb. How much of lost? Emission minus absorption. The resultant what loss, no? So therefore, power lost by the ball at 50 degrees Celsius is equal to power supplied by the heater. So therefore, what should be this answer? 20 watt only. You no need of any calculation. Okay, no, so there's a one part. Okay, next, let's come for the second part. Once again, assuming Newton's laws of cooling to be valid, calculate the rate of loss of heat to the surrounding when the temperature of the ball is 30. Okay, now there's a very good condition he has brought it. So here I think arrows I'm shown. So when it is at 30, temperature of this is, what will happen? It will be emitting what to write here? Power lost, no? So this will be power lost. The second part of the problem. Power lost when it is at 30 degrees Celsius or dq by dt. So if you are getting about dq by dt, power lost when the temperature ball is 30 degrees. So what should be that one? K, temperature of the ball 30, surrounding temperature 20 degrees. What is the value of K? 2 by 3 into 10. So 20 by 3 watt. So this will be 6.67 watt. So this much of power at 30 degrees, it will lose this much of power. Okay, fine. Now, assuming that the temperature of the ball rises uniformly from 20 to 30 degrees Celsius in 5 minutes, find the total loss of heat to the surrounding in this period. From 20, it will become 30 degrees uniformly. What is the mean temperature? From 20 will become 30, no? So what is the mean value of that? Again go for Newton's law. So this is what is the average temperature like that here. So power lost, average, okay, the third part of the problem. Average power lost. This should be equal to, what is the mean temperature? 30 plus 20 by 2 minus 20. Initial temperature was 20. K value 2 by 3. So 25 minus 2. This will be 5, 5 to 10, 10 by 3. So if this is the 10 by 3, so heat radiated is telling. So how many in 5 minutes? So what shall we do? So the total heat radiated Q is equal to, so power into, okay, this P lost average into time. So 10 by 3. What is the time? Delta T. 6 into, how much it is? 5, no? 5 into 60 seconds. Because it's there in power will be in watt, no? Joule per second. So it should be expressed in minutes, seconds here. So this should be equal to, anybody value?
1000.
3 1 ja 3 2, okay, 1000. Yeah, 1000 joules will be lost. Find the specific heat of a body. Then what you can write? Uh, okay, this heat radiated in 5 minutes. How much of heat is given by the heater coil? This is not our answer. Okay, we'll do one thing. Okay, I'm something. Okay, find the total loss of heat to the surroundings in this period. Okay, okay. I think. Okay, this will be our answer, and I think fine. I think total, no, that is. After the last one, find the specific heat capacity of the metal. How much of it is given by the heater coil in 5 minutes? We have for 5 minutes, we have we know lost power, no? So total Q net should be equal to ms delta T, and we know change in temperature also, the fourth part. So heat supplied by the heater coil. So how much it is? 20 into 5 minutes, or power supplied by heater coil, I'll write it, into delta T minus the total heat radiated Q ms delta T. And we know delta T. What is the change in temperature? In that 5 minutes, it will change from 30 to 20 degrees Celsius. The fourth part, let me write it here. Where is this 10 by 3? It is here. So power supplied by the heater coil will be 20 into, this is 5 into 60. This will be 1000. Mass specific heat 10. I'll write all the values so that will be easy for you. Mass of the body given. Okay, this part, okay. Find a joule per kg per Kelvin. Newton's laws of heating, cooling is what we know. So some problems can be like this. Only thing is student has to fight with the situation very clearly. Okay, let me have some brief one more. I'll take only 5 minutes. No, it can